All right, let's talk about energy in the form of light or a light wave. It's also called electromagnetic radiation. And it's the flow of energy through the electromagnetic field. So it's a wave. So let's think about what a wave is. So let's draw a little ocean wave. There's our little ocean wave. Maybe we've got our little island over here, and then maybe we'll put a little palm tree over here as well. So if we think about the ocean wave, it's energy flowing through water. And you can tell that has a lot of different properties than something that's like mass, right? If we have a ball, we can tell exactly where that ball is. We can tell its position. We can tell that kind of stuff. But where is this wave? This wave is throughout this whole area, right? It doesn't have a definite mass or a definite area. Another example of wave is sound, right? Sound is energy flowing through air. Right, so here's a picture of a sound wave, right? You've got a little speaker. It moves particles, air particles, and then those air particles hit your ear, and you've got little sensors in your ear that change these waves into sound. And so light's very similar to that, right? But waves and energy are very different than matter, right? We can't describe waves like matter. You know, if you want to ask yourself a question like how much does sound weigh, it doesn't really make a whole lot of sense, right? It's not matter, it's energy, it's something different. Where is the sound? Well, it's everywhere, right? It's much different than matter. So light is also a wave, right? And so it's an energy flow. In this case, we're through the, it's an electromagnetic radiation. So it's through the electric and magnetic fields. And these fields exist all around us. And anytime they're kind of disturbed in a particular way, we can see light. So there's just a little diagram there. You can see there's little waves where one is an electric field and one is through the magnetic field. One cool thing about light is that it's very fast. And we can observe that, you know, in our normal life when we think about lightning and thunder. Right, when you think about some kind of lightning or thunder happening, the first thing you see is the lightning. So you see it first, and then you hear it later. Right, you see a big flash in the sky, and then a couple seconds later, then you hear the thunder. And that's because of the differences of these waves. So the speed of light is extremely fast. It gets the constant c, and it's equal to about 2.998 times 10 to the 8 meters per second, right? This is an exponent. So if you want to write it in the non-exponent, it'd be 299,800,000, right? So 299 million. Whereas the speed of sound is much slower, and it's only equal to 340 meters per second. So you can see that they're much different, and that's why we can see lightning before we hear it. And the cool thing about this is you can actually calculate how far away lightning is depending on the difference of when you see it and when you hear it. So it's like a fun physics exercise.